So, what really happens after a developer hits Git push? Well, it's not magic, it's a journey. Today, we're going to follow a single piece of code as it travels through the entire Google Cloud software supply chain, all the way from a local machine to a secure, ready to deploy artifact. So, let's trace that path together. Okay, so we're going to start right at the beginning, in a version control system. From there, we'll see how that code gets built and packaged into what we call an artifact. And, super importantly, how we secure that artifact against vulnerabilities. Then, we'll check out the automation tools that work behind the scenes. And finally, we'll pull it all together and see the complete GCP toolkit in action. All right, first up, managing your code's journey. This is all about getting from that developer commit to a secure central repository. You know, our journey has to start with the absolute foundation of any modern software project, managing the source code. Before we can build, test, or deploy anything, we need a single source of truth that every person and every system can rely on. Okay, these commands you see here, they are literally the engine of collaboration. Commit is how you save your work on your own machine, push is how you share it with the team, and pull is how you get the latest stuff from everybody else. It doesn't matter if you're working alone or with a team of hundreds, these actions are what turn your individual effort into a shared project. Now, how you use those commands really comes down to your branching strategy. Are you doing trunk-based development, where you're pushing pretty much directly to the main branch for super fast feedback? That's a huge favorite in DevOps circles, but believe me, it requires some seriously robust automated testing. Or are you using feature branches to keep all the work separate until it's ready for a pull request? And look, this choice is so critical because it directly changes how your automated build and test pipelines get kicked off. So where does this code actually live in Google Cloud? Well, its home base is Cloud Source Repositories, or CSR. Just think of it as a private, super secure home for all your Git projects, built right into the GCP ecosystem and ready to connect to everything else. And let's be super clear here. Cloud Source Repositories isn't trying to be the next GitHub. It doesn't have all the flashy community features or those advanced pull requests, but here's its superpower, that native integration. Connecting it to Cloud Build or managing who has access with IAM is just seamless, because it's all part of the same family, so it just works. Okay, and this brings us to a really crucial point, especially if you're studying for any of the certifications. To let a developer push code, you don't make them an admin. Remember that principle of least privilege? It means you give them the source.writer role. That's it. It's exactly what they need, and absolutely nothing more. Okay, so our code's been pushed. The CI pipeline does its thing, and it builds something, a container image, maybe a Java package, whatever. That finished product, that's what we call an artifact. And, of course, it needs a place to live. And that's where we meet Artifact Registry. You can think of this as Google Cloud's modern digital warehouse for all of your software artifacts. It's really the one-stop shop for everything your pipeline spits out. And this chart, it shows you just how versatile this thing is. I mean, this is the key thing to remember. It's not just for Docker containers anymore. Nope. You can store your NPM packages, your Python wheels, your Debian packages. You can even store your Kubernetes Helm charts all in the same place. So you've probably heard of the older service, Container Registry, right? Well, as you can see here, Artifact Registry is hands down the successor. Just look at that top row. It handles all sorts of formats, not just Docker images. It also gives you way more control with repository-level permissions. It is absolutely the recommended path forward for any new project. So here's the exam tip, loud and clear. If a question mentions storing any kind of artifact, package, container image, you name it, Artifact Registry is the answer you're looking for. It's the modern way. All right, so our artifact is tucked away safely, but is it actually secure? See, storing something is really only half the battle. We have to make sure it doesn't have any hidden dangers lurking inside. And this right here is where Artifact Registry absolutely shines. It's got vulnerability scanning built right in. The second you push a container image, it's automatically scanned. But it doesn't stop there. It keeps on scanning, protecting you even when new vulnerabilities are discovered weeks or months down the road. That's huge. And you know what the best part is? Getting this set up is just incredibly simple. You enable one API, you flick a switch in the settings, and bam, you're protected. And if you want maximum security, you can hook it into something called binary authorization to completely block deployments if there are critical flaws. Okay, listen up, because this might be the single most important rule in all of container management. That latest tag, it's a trap. It's completely unpredictable because it can point to different images at different times. For production, you have to use specific, unchangeable tags, like a version number or a git commit hash, so you know exactly what's going into production every single time. No surprises. So that no latest rule is just one piece of the puzzle. You also want to use the smallest base images you can to reduce your attack surface. Always scan every single image you push, and have policies to clean up old stuff to save money. Do all this, and you've got the recipe for a clean, secure, and super efficient registry. Okay, so our main CI/CD pipeline is chugging along nicely. But what about all the other stuff that needs to happen? The side jobs, like generating a report every night, sending out email notifications, or processing a bunch of images that users just uploaded. That's where asynchronous automation comes into play. Now, GCP gives us two main tools for this, and it's so important to know which one to use. Think of Cloud Scheduler as your classic cron job. It runs that nightly report based on a time schedule. Cloud Tasks, on the other hand, is for spreading out a large amount of work that you kick off from your application, like processing thousands of those user-uploaded images without slowing your main app down. So let me put it this way. Scheduler is all about when something runs. Tasks is all about managing a huge volume of work you need to get done. All right, we've made it. We've followed our little piece of code all the way from the developer's keyboard to a secure, stored artifact, all backed up by some powerful automation tools. So let's do a quick recap of the complete toolkit we've just put together. Okay, time to lock in the key takeaways. Ready? Cloud source repositories for your native Git hosting. Artifact registry is the modern home for all of your packages. You should always enable vulnerability scanning, and please never, ever deploy the latest tag in production. And finally, remember to use Cloud Scheduler for time-based jobs and Cloud Tasks when you need to distribute a large volume of work. And that really brings us to our final thought here. Automation is awesome, but it's only half the battle. This journey has shown us the tools to not just build and store our code, but to secure it every single step of the way. So the real question I want to leave you with is this. How can you take these ideas and apply them to make sure your own software supply chain isn't just fast, but truly resilient and secure?
We hope you enjoyed this video. Like and subscribe for more Apex insights.